there are several common types of triggers, and I want to bring this to your attention, okay? So when we talk about triggers here, we are talking about triggers related to the relational database management system. But today, in the larger environment, trigger is a loaded term, overloaded term. Okay, so in a cloud environment, you have triggers. For example, in Azure, right? You have triggers, and in a cloud environment, when we talk about triggers, the triggers may be related to relational database management systems. It may be related to NoSQL database management systems as well. Okay, so triggers have been overloaded nowadays. But here, when we talk about triggers, we focus on the relational database management system. Okay, so triggers for a relational database management systems are related to transactions. Transactions require synchronous updates, right? So all the related data will all need to be synchronously updated before the processing continues. So it's a transaction. But in the larger context, like in a cloud environment, when we talk about triggers, it may be related to a transaction. It may not be related to a transaction. Okay, so in a cloud environment, when we say triggers, then the trigger may be related to transactions. It may not be related to a transaction too. Okay, so it's a little bit confusing, but just keep this in mind. Now we are talking about triggers related to the relational database management systems and related to transactions. So there are several popular types of triggers. We have DML triggers, we have DDL triggers, we have logon triggers. Triggers are event driven. So triggers run in response to an event. If we have DML triggers, then DML triggers run in response to insert, update, and or delete. Okay. If we have DDL triggers, DDL triggers run in response to data definition language commands such as create, alter, drop. If we have logon triggers, then the logon triggers run in response to creating a new session. Okay. And another way to categorize triggers are after triggers versus instead of triggers. And here for SQL Server, after triggers will run after the related command is complete or after the related event is complete. Remember, triggers run in response to some events, right? Those events most likely will be a command. So if we have after triggers, then after triggers will run after the related command is complete. So if it's related to insert, then insert will run first. Once insert is complete, then after trigger will run. Okay, so usually after triggers, that's pretty common. SQL Server or other relational database management systems, or even for NoSQL database management systems, they all have about the same behavior. Then we have instead of triggers. Instead of triggers, that's a little bit tricky. Okay, so if we have SQL Server, we create an instead of trigger, then remember, triggers are run in response to events, right? Those events are some SQL commands. If we have instead of triggers with SQL Server, the instead of trigger will run, but the related command will not run. So if your application, your users run or run a command which is related to the instead of trigger, that command initiated by your application, your users will not run. Instead, your instead of trigger code will run. That's for SQL Server. For other database management systems, usually they have a different name. They say before trigger. Before trigger is a very common term. If you have a before trigger, then the trigger code will run. After your trigger code is complete, the related command will run. Okay. Usually, people compare before triggers to instead of triggers, but there are some tricky, subtle differences. With SQL Server, the related command will not run. Your instead of trigger code will run, right? When we compare, for example, the before trigger with the Cosmos DB to instead of trigger with SQL Server, then if you have a before trigger with the Cosmos DB, your trigger code will run. Once your trigger code is complete, the related command will run. Okay, so I've said a lot. It might be confusing, but I think it's important that I bring these things to your attention. Once you work on the details that I just mentioned, then it will make a lot more sense to you. Okay, so triggers sometimes could be a little bit confusing. And another very important concept about triggers, usually it's always true. Okay, so triggers are related to a transaction or some logical unit of work. Therefore, the trigger can control that logic unit of work or can control the transaction, meaning the trigger code can commit or roll back the transaction, can determine the results of the logical unit of work depending on your business logic. Okay, so this is very important. And we have mentioned several important characteristics of triggers. Triggers are related to some events, right? So the events are usually a SQL command. Another thing we have not mentioned yet is trigger is usually tightly integrated with a table. So for the relational database management system, the trigger is tightly integrated with a table, could be a view as well. In the NoSQL database world, a trigger is tightly integrated with, for example, a container in Azure, right? Cosmos DB, or some similar architectural components. So several things I want to reiterate before we dive into details. Triggers run in response to events. Those events are commands, right? Triggers are part of a transaction or a logical unit of work. Therefore, triggers can control the transaction or the logical unit of work. And also triggers are tightly integrated with a table or a container. Okay, those are the key things we need to keep in mind before we dive into details. And I have a very simple example here. And this trigger is related to insert. And it's after, okay. And it's integrated with this table. So let's go over the key points we just mentioned. A trigger is in response to a command, right? In this particular example, it's insert. A trigger is tightly integrated with a table. In this example, it's this table, sales start opportunity. And the timing is after, okay. And usually we use after trigger for auditing and some other purposes. So create a trigger. When we create a trigger, we do not specify the schema because the trigger is tightly integrated with the table. Whatever schema the table is in, that trigger is in as well, right? Probably it's superfluous to say that, but trigger is tightly integrated with a table or with a view. So create a trigger, give the trigger a name, integrate it with this table. It's after insert, and then the body of the trigger. Usually in the body of the trigger, we say no count on. No count on will help with integration because triggers are usually run behind the scenes. And when we run SQL code, we will get response from SQL saying, for example, 5 rows affected, right? Or 20 rows affected. And SQL trigger code is run behind the scenes. And usually when we do integration, for example, you have a data mining tool which is integrated with your database. Your data mining tool will run some code of its own to get to the database. And then the data mining tool will look for the result from the database server, such as 5 rows affected, 5 records affected, right? And the trigger code may also be run, but the trigger code is run behind the scenes for enforcing business rules and things like that. You don't want the row count of your trigger code to interfere with the row count of your data mining tool. I'm sorry. We don't want the row count of your trigger to interfere with the row count generated by the SQL code sent by your data mining tool, right? I think that's a more precise way to say it. So therefore, for integration purposes, we usually say set no count on. We care about only the regular code run by your data mining tool or a tool. We want that row count. We don't want the row count created by your trigger code. Therefore we say set no count on. So we disable the row count for the trigger code. Okay, so for integration purposes. And we are doing auditing. So insert into our audit table 3 columns, select these 3 values. First column is I.opportunity ID. Okay, I is inserted, is here, down here. And then the second column, second value is I, that's just a character value. And third value is system date, that's just a date, okay. So we need to pay attention to this I.opportunity ID. I is inserted. Now we need to talk about two very important virtual tables when we work with triggers. So let's do this. When we do SQL programming, when we develop triggers, run triggers, or merge or output, SQL Server maintains these two virtual tables. These two virtual tables are memory resident. They are virtual tables, okay, just like variables. They live in memory. They are in scope as long as the related trigger code or related command is still running. And deleted and inserted are the names of these two virtual tables. They are related to three DML commands: insert, delete, update. So when we insert data, then the data which is being inserted is stored in inserted. When we delete data, data which is being deleted is in deleted. When we do update, then old data is in deleted, old new data is in inserted. Okay, so those are very, very important virtual tables, just like variables in memory. They are related to DML commands, insert, delete, update, and we have to use them when we develop triggers. Without them, we cannot develop triggers, okay? Keep this in mind, very, very important. But when we use output and merge, they are also available. Any question?